So hello students, in this lecture we will discuss disjoint sets. So disjoint set you already know. Set means the collection of elements. Okay. Now what is meant by disjoint set? Okay. So disjoint sets are basically the sets or multiple sets which does not contain any common value. Okay. That's why it is called as a disjoint set. Okay. So see here. Here we have a definition. Two sets are called as disjoint sets if they don't have any elements in common. Okay. So if in the two sets, if there is a one common element exists, then we cannot say that though both the sets are disjoints. Okay. So if we are talking about disjoint sets, then there should not be any common element. So where we are using this disjoint sets? So generally in the graph theory, we are using this disjoint set to identify the cycles in the graph. Okay, whether the cycle is present in the graph or not. Okay, the disjoint set is the data structure used to store such a sets. It suppose following operations. Okay, now which operations we can perform on the disjoint set, that we have to see. First one is merging two disjoint sets to a single set union operation. Okay, so definitely you learn set theory in your schooling. So union is a very popular operation whenever we talk about sets. Okay, so union means what? We are combining two or more sets. Okay, so that is union operation. Now finding the representative of disjoint set using find operation. Okay, so what is this? That I will tell you with the help of example. Finding means what? If we want to search anything, any element, then how we can do that. Okay, then check if two elements belongs to the same set or not. We mainly find representation of both and check if same. So we need to find out whether the elements are present in the same set or the different set. If it is present in the same set, then definitely we can say that there is a cycle. There is a cycle present in the graph. Okay. If both of the elements or multiple elements are belonging to multiple sets or different sets, then we can say that there is no cycle. Okay. So now guys, you can write theory related to disjoint set, which is very easy. Now guys, this is the question which they ask you in the model question paper. So they are asking, consider a tree created by the weighted union function on the sequence of units. Okay, so guys, you have to first of all create a tree. Okay, to create the tree guys, they have given one function, that is union function. Okay, so there are multiple functions like union 0, 1, union 2, 3, union 4, 5, union 6, 7, union 0, 2, union 4, 6 and union 0, 4. Okay, I will tell you how to do this tree representation, okay, or how to draw the tree using this. Then process the simple find and collapsing find on the 8 finds and compose which is efficient. Okay, sorry, this is not compose, this is compare, I think so. Compare which is efficient. Okay, so this is not compose. Okay, so guys, what I am doing, first of all, I will try to draw the tree with the help of this union functions which is given in the question. Okay, so what I am doing, I am writing these functions here just for my reference. Okay, so union 0, 1, union 2, 3, union 4, 5, union 6, 7, union 0, 2, union 4, 6, union 0, 4 is given. Okay, now what I have to do, I have to represent these operations, these functions with the help of two things. One is graphical presentation and second one is array representation. Okay, so first of all, what I am doing, First of all, I am drawing a graphical representation, or I am writing here a graphical representation. Okay, so if you have the graphical representation, after that array representation is very easy. Okay, so first of all, what I am doing, so see here very carefully. So first function is union 0 comma 1. So guys, here you have to draw two nodes, that is 0 and 1. Okay, and one of the node becomes a parent node. Now it's up to you guys which node you want to become a parent. Okay, so here 0 and 1, two nodes are there. Okay, so I am assuming 0 is the parent of 1. Okay, you can make 1 as a parent also, no issue, no issue. So union 0 comma 1. Next is union 2 comma 3. So guys, 2 comma 3 both are independent. Okay, earlier we draw the graph for 0 and 1, we draw the tree for 0 and 1, but now we got 2 3. Okay, so different tree we have to draw. So 2 3. Now here also I am making 2 as a 2 as a parent. Okay, next I have 4 5. Okay, so I am making 4 as a parent, 5 as a children. Okay, so I am drawing the tree like this. Okay, so here I am showing the arrow. Okay, here I am showing the arrow. Now next is 6 and 7. 6 and 7, this is 6, this is 7. Okay, I am making 6 as a parent, that's why I am writing like this, 6 7. Okay, now guys, next is union 2 comma 5, union 0 comma 2. So see now guys, 0 node we already have, 2 node we already have. Okay, so we need not to make other nodes like 0 nodes and 2 nodes again we need not to draw here 0 node and 2 node. Okay, so whatever the node we already have, now what we have to do, we have to merge these two nodes now. Okay, so that's why this is called as a disjoint set, guys. See, this is one set, this is the one set. Okay, so set 1 is containing 0 1, set 2 is containing 2 3, and now you have to do union between 0 and 2. Okay, it means what? It means you are drawing the edge between 0 and 2, and if you are drawing the edge between 0 and 2, then these two trees is not a disconnected trees. Okay, it's not a disconnected tree, then it is comes under a single set. Okay, if you join this 0 and 2, then it comes under a single set. Okay, so guys, here I am doing a union operation now. Union. So 0 and this is 1. Okay, now guys, again I am making here 0 as a parent. It's up to you guys who to whom you want to make a parent. Okay, so see, 0 and 1, 2 elements are there, 2 and 3, 2 elements are there. Okay, so both the trees is having a 2 elements. Okay, so we are making 0 as a parent. Okay, and then 2 and then 3. So see here guys, we draw this edge. Okay, so this edge is basically showing what? 0 is the parent of 2. Okay, now I want to merge these two trees. That's why I merge like this. You can make 2 as a parent also, no issue. Okay, no issue. Because 0 and 1, both this tree is having 2 elements and this tree is also having 2 elements. Okay, so it means both the tree is having same weight. Okay, 2 elements. Okay, so you can make any element as a parent element. Okay, so here I am making 0 as a parent. Okay, no issue. Now guys, next what they are saying, so this is done, 0 2 is done. Then next they are saying 4 6. So guys, 4 is present here, and 6 is present here. Both are disjoint set. What we have to do? We have to union these two sets. Okay, we have to take a union of these two sets. Okay, so again here I am doing union operation, union. Now guys, again both the tree 4 5 and 6 7, both the trees are having two elements. Okay, so we cannot say that this tree is a superior tree, this tree is a superior tree. Okay, we cannot say like that. Okay, so you can make any tree node as a parent. Okay, so you can make 4 as a parent or 6 as a parent, it's up to you. So here I am making 4 as a parent. Okay, so here I am drawing like tree like this. Okay, so basically what I am doing a merge operation. Okay, I am doing the union operation here. We are doing the union operation here among the two sets. Okay, and merging operation is basically on graphical representation. Okay, so if we are combining two trees means we are merging the two trees. Okay, so that's why this is union operation. So this operation is over. This operation is over. Now next operation is union 0 4. So guys, you can see 0 is here and 4 is here. Both are in different set. Both are in different set. What we have to do? So first of all, we have to do a union. First of all, we have to do union. So union we have to do here. Union. Okay. So I am drawing this tree here. Okay. So first of all, you have to do union. Okay. Now guys, again you have to see in both the trees, 4 elements are there. Okay. So in the tree 1, this is, let us assume that this is tree 1. This is tree 1 and this is tree 2. Both the trees is having 4 elements. So we cannot say that this tree is a superior tree or that tree is a superior tree. Okay. So let us assume that if tree 1 is having 6 elements and tree 2 is having 4 elements, in that case 6 element tree is superior tree. So we have to make that tree as a parent tree. Okay. But in this case guys, our tree 1 and tree 2 both is having 4 elements. So we cannot say that any one of the tree is a superior tree. So what I am doing, I am now merging these two trees. I am merging these two trees. Okay, so I am making 0 as a parent. I am making 0 as a parent. Okay, I am making 0 as a parent. Just a minute. This is 0, then this is 1. Okay, then I have this 2, I have this 3. Okay, now I am merging this 4 here. I am merging this 4 here. Okay, so 4, this is 5, this is 6, okay, and this is 7. Okay, so see, this is my graphical presentation. This is my graphical presentation. Okay, now let us assume that if you want to search any element, then you can directly comes to a root 0 and then comes to 3. If you want to search 6, then comes to 0, then 4 and then 6. Okay, so this is how you can do find operation. Now guys, there is a one more technique, that is array technique. Okay, that is array technique. So if you are comfortable with this graphical representation guys, then array technique is very easy. Okay, so in the array technique what we have to do, see, now here I am writing array technique. So here I have the array technique. So in the array technique, first of all you need to see how many nodes you have. So guys, currently I have 8 nodes. Okay, and these nodes are starting from 0 to 7. So guys, these nodes are starting from 0 to 7. So it's very easy to draw the array because array index is always starts from 0. Okay, so we can use array index as a node value. Okay, but let us assume that if in the question paper they given you the nodes from 1 to 8, then in that case guys, you have to be very careful because on the 0th index of the array you have first node, on the first index of the array you have second node, on the third node of the third index of the array you have fourth node. Okay, so you have to be very careful. In this scenario guys, in this question, they have given the node values from 0 to 7. So it's very easy to draw the array for this. Okay, so what I am doing, here I am drawing one array. This is a very big array I am drawing because I have to do a lots of changes here. Okay, I have to do lots of changes here, that's why. I have to do lots of changes here, that's why. Okay, so here I am drawing different 8 blocks. Okay, these are 4, 5, 6, 7 and this is 8th block. Okay, now here I am giving indexing. Okay, but now here my nodes are starting from 0, that's why the index values and the node values are same. But let us assume that if your nodes starting from 1 1 to 8, then in that case guys you have to write 1 2 3 4 5 6 7 8. Okay, forgot about the indexing of the array which is starts from 0. Okay, but now here our node starts from 0, so that's why I am writing here 0 1 2 3 4 5 6 7. So 0 to 7 nodes I have. Okay, now initially what I am assuming that all the nodes are the root nodes. Okay, so what is the reason behind this? So reason behind this, we are considering every node as a independent node. Okay, it means every node is not involved in any of the set. Okay, every node is not involved in any of the set. We are considering that every node having its independent set. Okay, in that set only one node is there. Okay, so let us assume that if in the set only one node is there, so who is the parent of that node? Okay, if one node is there, who is the parent of that node? So parent is nothing. Okay, so see, in the set if you have only one value, so who is the parent of that value? No one is the parent of that value. Okay, so that's why guys, if no one is the parent, so we are assuming that minus 1 is the parent, minus 1 is the parent. So I initialize this array with the minus 1 because I am assuming that each element of this set is independent. Okay, each element of this set or each node of the graph is independent. Okay, now the first thing they have given is union 0 comma 1. So 0 comma 1, so here I am drawing 0 and here I am drawing 1. So this is 0 is the parent, 1 is the children. So guys, you can make 1 as a parent 1 as a parent and 0 as a children. Okay, it's up to you guys, but I am using this thing like 0 is the parent and 1 is the children. So what I need to do? Okay, if the one's parent is 0, so what I need to do? I need to change this array. Okay, so instead of writing a minus 1, now one element 1 or node 1 is having a parent what? 0. So here I will write 0. Here I will write 0. Here I will write 0. Okay, who is the parent of 0? Parent of 0 is no one. So minus 1 is there. But guys, instead of writing minus 1, what I am writing here? I am writing here minus 2. Why I am writing minus 2? So minus is representing that the node is the root node. Minus is representing what? Node is the root node. And 2 is representing what? The number of sets, or sorry, the number of node is present in that set. Okay, so set 0. So let us assume that this is my set name. Set 0 is having 2 elements now. Which 2 elements? 0 and 1. Okay, so this minus 2 is representing what? Minus is representing root and 2 is representing the number of nodes in that set. Okay. Next guys, they are asking union 2 3. Union 2 3. So here I am drawing 2 3. Here I am drawing 2 3. Okay. Now guys, 2 is the root. 2 is the root. So 2 is the root. 3 is the children. Okay, so 3 is the children. So who is the parent of 3? 2 is the parent of 3. So instead of writing minus 1 here, now guys, instead of writing minus 1 here in the third index, what you have to write? You have to write 2. You have to write 2. Why we are writing 2 here? Because 2 is the parent of 3. 2 is the parent of 3. Okay. Now what is there in the 2? In the 2 minus 1 is there. Okay, so no issue. 2 is the root, that's why minus sign is required. 2 is the root, that's why minus sign is required. But instead of writing a minus 1, now I will write here minus 2. Minus 2. Minus 2. Why I am writing minus 2? Minus represents root and 2 represents the number of nodes in that set. Okay, so second set or second node is having 2 values, 2 nodes in their set, in that set. Okay, now guys, next union is 4 5. 4 5. Okay, 4 4, 5. Okay. Now again 4 is the parent, 5 is the children. Okay. So 5 is the children of 4. So instead of writing minus 1 here guys, what I will write? Instead of writing minus 1, what I will write? 4 I will write. Why? Because 4 is the parent of 5. 4 is the parent of 5. Okay. And now here in the 4 I have minus 1. So instead of writing minus 1, I will write minus 2. You know why I am writing minus 2? Because minus represents root, 4 is the root, and 2 represents two nodes are there. 2 nodes are there in that set. Okay. Now guys, next union operation is 6, 7. So 6, here I will write 6. Here I will write 6. 6, 7. Now 7 is the children of 6. So instead of writing a minus 1 here inside the 7, what I will write? I will write 6. Okay, because 6 is the parent of 7. 6 is the parent of 7. Who is the parent of 6? No one is the parent of 6. Up till now, no one is the parent of 6. So what I will do? I will write here minus. I will write here minus because minus represents it's a root node. But instead of writing a minus 1, I will write minus 2 because minus 2 represents what? Minus 2 represents what? Minus 2 represents the two nodes in that set. Okay. Now guys, next union operation. Next union operation is 0, 2. Okay. So guys, now you have to union these two. These two you have to union. These two you have to union. So guys, just now we did that operation here. Okay, just now we did that operation here. So see here we got this kind of a tree. Same tree I will get here. Same tree I will get here. First of all, I am drawing the tree, and after that I will tell you how to make changes in this array. Okay, first of all I am drawing the tree. So 0, this is 1, this is 2, and this is 3. Okay, so first of all guys, after drawing this tree, we have to make the changes in this array. Okay, now who is the parent of 3? Parent of 3 is 2. So parent of 3 is already there, 2. Already there, 2. Parent of 3 is 2. Who is the parent of 2? Parent of 2 is 0. And here the parent of 2 is minus 2. Because earlier 2 is the root. Earlier 2 is the root. Okay, but now 2 is not a root. Now 2 is not a root. After this union operation, 2 is not a root. 2 is the children of 0. So that's why guys, instead of writing here minus 2, I will write 0 now. I will write 0 now. Okay, so remember this guys. After this union operation, 2 is not a root. If it is not a root, then minus sign is not there. Okay, so what we have to write? We have to write the parent. We have to write the parent. So parent is 0. Parent is 0. So that's why I am writing 0. Come to 1. Come to 1. So 1 is the children of 0. So 1 is the children of 0. Okay. So 0 is already there guys. So we need not to make any changes. 0 is already there. Okay. Now come to 0. So 0 is the root. 0 is the root. So minus operation, minus sign is there. Minus sign is there. But now in this 0 set, we have 4 elements. Okay, before this union guys, we have 2 elements, but now we have 4 elements after this union. So instead of writing minus 2 here, what I will write? I will write here minus 4. Okay, minus 4 I will write here. Okay, so I hope this is done. Okay, I hope this is understood. Okay. Now next union operation. Next union operation is between 4 and 6. So guys, now I will do the union operation between 4 and 6. So first of all, I am drawing the diagram. After that, I will make the changes in the array. Okay, so after drawing the diagram, making a changes in the array is very easy. Otherwise, you can directly do the changes in the array. But for that, you have to be very careful. Okay, so it's better to draw the diagram first. Okay, so here I am making 4 as a parent. 5, then 6, and then 7. Okay, by looking at this diagram guys, we can easily make the changes in our array. Okay, so first of all, concentrate on 7. So 7 is the children of 6. Okay, so see guys, 7 is the children of 6. So 6 is already there. 6 is already there. We need not to make any changes guys. Okay, then comes to 6. Okay. Now 6 is the children of 4. Earlier 6 is the root. Earlier 6 is the root. But now the 6 is the children of 4. 6 is the children of 4. 6 is the children of 4. So guys, instead of writing a minus 2 here, what I will write now? The parent. Who is the parent? 4 is the parent. So now I will write 4 here. So now I don't have either minus sign. Why minus sign is not there? Because 6 is not a root now. 6 is not a root now. 6 is the children now. Okay. So 4 I am writing. Why 4 I am writing here? Because 4 is the parent of 6. 4 is the parent of 6. Now guys, next is 5. So who is the parent of 5? 4 is the parent of 5. 4 is already there. So we need not to make any changes. 4 is already there. Okay. Now comes to 4. 4 is the root. 4 is the root. Means minus sign is there. But here we have a minus 2 now. But what this 2 represents? 2 represents the number of nodes in that set. But now guys, 4 is having 4 nodes in the set. 4 node in the set. That's why guys, instead of writing minus 2, what I will write? I will write minus 4 here. Okay. Now guys, come to the next union operation. Next union operation is between 0 and 4. Okay, so next diagram I will draw here. So we have to do the union between these two. So what I am doing? I am writing 0 here first. Then I am writing 1. Then I am writing 2. And then 3. So I am drawing the diagram first guys. After that I will make a changes in the array. Okay. After drawing the diagram, we can easily make the changes in the array. It's very easy then. Okay, directly making a changes in the array is little bit difficult. Okay, so guys, this is my final diagram which we already got here in the graphical representation. Same diagram we got here also. Okay, now I will make a changes in my array. Okay, so first of all, start with 7. Who is the parent of 7? 6. So under the 7 we have a 6 here. So no need to change. Then come to 6. Who is the parent of 6? 4 is the parent of 6. So under 6 we have a 4. So no need to make any changes. Who is the parent of 5? 4 is the parent of 5. So under 5 we have a 4. So no need to make any changes. Come here, 3. So who is the parent of 3? 2 is the parent of 3. So already we have a 2 under this 3. So no need to make any changes. Then who is the parent of 1? The parent of 1 is 0. So already 0 is there guys. We need not to make any changes. Okay. Next. Now come to 2. Who is the parent of 2? 0 is the parent of 2. So we already have 0 here guys. We already have a 0 here. Under 2. So we need not to make any changes. Now come here on 4. So who is the parent of 4? Parent of 4 is 0. And what we have here? Under 4 we have minus 4. Minus sign represents it's a root and 4 represents the number of nodes in the set. Okay. So guys, instead of writing minus 4 here, now we have a parent. Okay. So I will write here 0. Okay. So remove this minus 4. I will write 0 here. Okay. Now guys, next come to 0. So guys, 0 is the root. That's why minus sign is there. But this 0 is having how many elements in the set? Total 8 elements in the set. But here we have minus 4. So instead of writing a minus 4 here guys, now I will write minus 8. So guys, whatever the value you got here, that is your final array values. Okay, so I am drawing this array once again here. With the final values. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. These are my nodes. Okay, so 0 is minus 8. This is 0. This is 0. This is 2. This is 0. This is 4. This is 4. This is 6. Okay. Now, let us assume that if I want to search any element, okay, how I will search? Let us assume that I want to search 7. So I will come to 7. Then I will go to 6. Then I will go to 4. And then I will go to 0. And then I will go to minus 8. Minus 8 means basically a root. Okay, so this is how we need to search the element. Okay, let us assume that if you want to search 4, so come to 4, directly come to 4. Okay, what is the value inside the fourth index? 0. So come to 0, and here minus 8 is there. Okay, minus 8, minus means root value. Okay, so guys, this is what the find. This is what the simple find. Okay, but in the question they asked you about collapsing find, guys. Collapsing find. What is meant by collapsing find? Okay, so this is also very easy, guys. Let's see. Collapsing find. Okay, see, let us assume that if I want to find 7, so where you are going? If you want to find 7, you are going to 6. Okay, then 6 you are going to 4. Then 4 you are going to 0, and 0 is your root. Okay, so ultimately you have to reach the root. Ultimately you have to reach the root. So what we can do? We can collapse these all the nodes to the root 0. Okay, means we can attach all these nodes directly to the 0. So instead of indirect connection to the 0, we are connecting all the nodes directly to the 0. Okay, so which kind of a graph I will get after collapsing? See, it's very easy. 0 is my root. 0 is my root. So what I will get? I will get here 1, here 2, here 3, here 4, here 5, here 6, and here 7. Okay, like this. So this collapsing find is very easy. Okay, if you come to 0, then you can directly reach to all the elements, all the nodes, whatever the nodes you want to find. Okay, so this is collapsing find. So I hope you understood this concept, guys. Disjoint set. If you have any difficulty, if you have any doubt, again you rewatch this video and focused on this graphical representation or graphical presentation. If you are comfortable with the graphical presentation, then drawing this array is very easy, guys. This is very easy. You just need to follow my technique. Just see this video once again. You will